Good afternoon, chemistry students at Byron Center High School. My name is Alyssa Schaefer, and I'll be your host for this special newscast. Just last Saturday, scientists at the John B. Pierce Laboratory in Connecticut created new designs for hot and cold packs. The results of these hot and cold packs proved to be very successful and are now distributed in stores throughout the United States. Yesterday, I had the opportunity to talk with Miss Danielle Colburn, one of the scientists in the group that created these hot and cold packs. Let me tell you the information that Miss Colburn gladly shared with us. The design and explanation of the hot pack and the cold pack I learned from Miss Colburn is very detailed, but also quite easy to understand. The first fact that is needed to understand these new products is the design. Miss Colburn has told me some information about the certain chemicals, potassium nitrate and calcium chloride, inside these new products that make these hot and cold packs successful. Now let's start with this new hot pack. Miss Colburn is at the John B. Pierce Laboratory, ready to tell us about its design and the detailed science behind how it works.
Thank you, Alyssa and viewers. I wish I could be at your studio in person, but a laboratory is a busy place and there are lots of things that have to be done as we continue to make progress in the scientific world. Anyways, welcome to the John B. Pierce Lab. What I'm going to share with you today is the design of our newest hot and cold packs. We'll start with our hot packs being sold under the name Exo Comforters. As you can see, these hot packs are contained within fun slippers. Exo Comforters are perfect for cold winter days when your floors are just too cold and socks don't cut it. The example I have here is a pair of our best-selling giraffe slippers, but Exo Comforters come in many different designs. Let's start with the basics. If you buy a pair of these slippers, you also get a couple of hot packs. You'll get numerous wears out of the Exo Comforters before you have to buy more hot packs to refill them. To activate the hot packs, you first have to put them into the pouch in the slippers. After they're in the slipper, just put the slippers on your feet and start walking. When you step on the hot pack, the capsule containing the salt will break, releasing the chemicals into the water in the hot pack. Don't worry, the outside of the pack is very sturdy, so you don't have to worry about it breaking. We did plenty of tests on the Exo Comforters before sending them to be sold. Now we'll get into the science behind the Exo Comforters. You know that stepping on the packs will cause a reaction to happen, but what does that mean? The salt contained within the capsule is calcium chloride. When calcium chloride and water are mixed together, an exothermic reaction occurs. This means that the calcium chloride releases the heat that it has within it. When the calcium chloride releases heat, the materials around it are warmed. So when the calcium chloride and water are mixed together, the calcium chloride gives off heat to the water. The water warms up and makes your slippers as cozy as they are. Let me show you a diagram so you can see what's actually happening. On this top line, we have CaCl2, calcium chloride, plus H2O, water. Down on this bottom line, we have Ca plus Cl2 plus heat. From the top line of the reactants to the top of this curve is the activation energy, which you can see here. That's the energy required for the reaction to occur. The reaction is spontaneous though, so it will happen on its own without outside influences. All you have to do is wear your slippers. The distance from the top line to the bottom line, shown here, is called the delta H. This symbol, right here, represents the change in heat. This graph represents the heat of the salt specifically. The heat of the calcium chloride starts higher, but ends lower after being mixed with the water. This represents the heat it is giving off. The delta H for this reaction will be negative because the calcium chloride ends with less heat than it began with. It is releasing heat into the water around it and warming it.
Very nice, Miss Colburn. The facts on how this hot pack activates is very interesting. The design is very creative also. I better understand now the meaning of the words exothermic delta H and activation energy. Now, Miss Colburn, I see you also have the cold pack right next to you. Would you mind explaining the second product?
I would love to explain our second product. Keeping with our name and themes, the cold pack slippers are called Endo Comforters. Sometimes you want to wear comfortable slippers after a hard day of work. These cold pack slippers are perfect for icing your sore feet and relaxing. You'll see that I have another variety of slipper with me for the cold pack. The idea is the same for the Endo Comforters. You have to place your cold packs into the pouches located within the slipper. Once your pouch is secure, you can start walking. Again, walking on the slippers will break the capsule, releasing a different salt into the water. Don't worry, the same guarantee comes with these slippers. Walking on the pouches won't break the whole thing, just the salt capsule. Let's talk about the science here. The salt within the capsule is potassium nitrate. When you break the capsule, the potassium nitrate and water begin to react. In this case, an endothermic reaction occurs. The potassium nitrate absorbs heat from the water surrounding it, causing the water to cool significantly. I have another diagram to show you that might clear things up. Here we go. You'll see that this graph is the opposite of the exothermic graph we looked at. This time, the salt starts on the lower line before reacting with water. We have our KNO3 plus heat. On the line up here, we have our K plus NO3 after reacting with the water. Our activation energy is much bigger here and is shown from the reactants to the top of the curve. From the reactants to the products is the delta H, again, the change in H of the reaction. Our potassium nitrate starts at a lower heat and ends at a higher heat. After it reacts with the water, it absorbs heat from the water surrounding it. The delta H for the endothermic reactions is positive because the heat within the salt is increasing. I hope this helps all you viewers and consumers get a better idea of the science behind the exocomforters and endocomforters.
Thank you very much for explaining your products to us, Miss Colburn. Those hot and cold packs seem like they could be really useful for treating body aches, injuries, or other needs. In a summary, when each salt is mixed with water, each salt reacts differently. When potassium nitrate salt reacts with water, the temperature drops. This is called an endothermic reaction because there's heat that is being absorbed, which results in a decrease in temperature. On the other hand, when the salt calcium chloride reacts with water, the temperature rises. This is called an exothermic reaction because there is heat that is being released, which causes the increase in temperature. These two processes are further explained by the endothermic and exothermic graphs that Ms. Colburn showed to us.
That's right, you summed it up perfectly. Thanks again for having me on the show. I hope you enjoyed our brief science lesson.
We hope to hear more wonderful news to come about these new products. Please visit us again, Ms. Colburn. This now wraps up our special NBC segment. We hope to see you all back here tomorrow. Goodbye.